Welcome to TFR Newsroom. Today we have with us once again Mark Holman, Director of Developer Relations at Equinix, and we are going to talk about the latest release of Tinkerbell, the all-in-one bare metal provisioning platform. Mark, first of all, it's great to have you back on the show.
Swap, thank you so much for having me back. I'm looking forward to talking about this today.
Yeah, so before we get started, can you tell me a bit about what exactly is Tinkerbell all about?
Tinkerbell is a project that we use internally at Equinix Metal's bare metal cloud. We call it bare metal provisioning, but really you could look at it as hardware provisioning. And I wish I could say it was a one-stop shop to running your own cloud, but unfortunately it's just one piece of a larger stack. Essentially what it allows you to do is go from racked and stacked networked machines to something that a user can actually use. And we do that through various workflows. But essentially what it does is get you from a machine that's waiting for a job into a state that a user needs it to be in.
You said that, of course, that it's used internally. How do the external teams or people, they leverage it? Is it through Equinix services that you offer, or they can themselves use Tinkerbell?
Tinkerbell is how we do bare metal provisioning within Equinix Metal. The open source project can be used by anybody for anything else. So if you're an Equinix Metal customer, you're using it, but you don't see it. It's sort of part of how we get the job done. Our open source users use it for a variety of roles, but it's always kind of the same thing, right? They have hardware that they want to provision, and they need tooling to do that. And what's interesting is that, there is already software in this space, but most of it was created pre-cloud native. So it's got a lot of assumptions in there that don't really scale very well anymore, or don't necessarily fit into people's workflows. Tinkerbell was built with a lot of cloud native concepts in mind. So for example, it consumes Docker containers. It's composed of microservices. You can interact with the whole thing through APIs. And what that means is that people who are using it now, and we can talk about some of those, I suppose, a little later, find that it's much easier to fit into their new cloud native application architectures. Now, this is especially important because I think there's been this perception for a while that people running on-prem hardware are, what you might call on the crossing the chasm curve, laggards. But what we've seen is that that isn't really the case. There are a number of reasons why people would be running their own hardware. Often it's because, they've gone to the cloud and then they found out that at a certain scale, they wanted to move back to on-prem because the economics changed when they got to certain either data scales or networking scales or compute scales or something like that. Often people didn't go to the cloud because they have certain compliance issues that they need to deal with in their jurisdictions. Sometimes they need specialized hardware. They have special performance constraints. So that's the type of person that is using this. And I think what's also starting to happen now, especially as we see both hybrid, multi-cloud, and edge happening, is that there's a whole new sort of raft of people getting into this area. And I'd be more than happy to talk more about why I think that happens.
Can you talk about what are the core components of Tinkerbell, the project?
So Tinkerbell is composed of 5 microservices, essentially. We're introducing a new one that I can talk about now. There's a microservice called Tink that does a lot of the work. And this is where workflows are stored, where we match up hardware to make sure that we're running the right workflow and the right hardware. And it relies on 4 other main components to get its work done. You have a component called Hagel, which is a metadata service, which stores a lot of information about where things are. You have a component called Boots, which intercepts DHCP requests from servers that are switching on, booting up, and then kicks off the rest of the magic. So for example, if a server switches on and it doesn't know what it's going to do yet, it'll send out a DHCP request, which will be intercepted by Boots. Boots then asks Tink, okay, this server has sent out a DHCP request, and it has, for example, this MAC address, but we can identify it in different ways. If we do have a workflow, Tink will then say, great, here's the workflow, and we go into something called OSI. Now, OSI is an in-memory operating system, and essentially what we do is we boot the in-memory operating system on the server that we'd like to provision. We figure out which workflow we want to use from Tink, and then we run each action. Those actions can be things like reformat the disks, set up RAID, a whole bunch of other things. But often what it comes down to is install an operating system, because users can't really use the box without an operating system. So we'll go through all those. Now, there is another one in there as well called PB&J, which is for power and booting. So at the end of all this workflow, what we'll often do is reboot the machine. Now that's changed slightly with some of our newer technology, because we can now actually kexec directly over into a running operating system. But PB&J is the fifth element in there, which allows you to restart the machine so it can come up in its desired state. Now there's one thing to add to that, which is that in this 050 release, we've introduced a new component called Hook. Hook is a drop-in replacement for OSI. So OSI is the in-memory operating system that does all the work before we reboot and give the machine to the customer. Hook, I think, is a fantastic example of where we've been able to learn with the community. A lot of our assumptions, of course, when we open sourced Tinkerbell, were very Packet and then Equinix Metal specific, because that's the area that we were working in. But by seeing some of the challenges that other people in the community were dealing with, we've been able to introduce Hook. Now, Hook is not only more generic, which means it applies to more people's use cases, but it's also significantly faster. So using Hook, which now relies on Linux Kit, we can deploy an operating system, for example, in something like a minute, which is about 90% faster. Now, this always would have been possible, but it's really the impetus from having to work with the community who had the desire to add their own operating systems, which caused us to look at this a little bit deeper. And now we're going to be taking that upstream development and deploying it across Equinix Metal as well. So that's a really good example of working with the community that seems to be working for everybody.
You're dropping this release today. Talk about what is new in this release, any highlights, key features that you are excited about.
I just mentioned Hook. Hook has enabled us to add a whole host of new operating systems very quickly. So in this release, you will have out-of-the-box support for, and this is off the top of my head, but RHEL, so Red Hat Enterprise Linux, Windows Server, Flatcar, CentOS, Debian, Nixos, and I believe Alma Linux is on its way as well. So a whole bunch of new operating systems there. And to go along with that, we've been doing a lot of work on documentation. So it should now be very simple for people to understand not only how we do this and to use it themselves, but also to add their own, which is one of the things that we're focusing on a lot. Now, as part of that, and it's not really part of the release, but it's related to the way that we're communicating with the community, we now have bi-weekly community calls that are staggered in US and EU friendly time zones. And we're starting to see a lot of people coming into those calls and asking questions and contributing, etc. The other big thing is cluster API. So a lot of people who want to use Tinkerbell because they're trying to make their bare metal into something that resembles a Kubernetes cluster. Now, after a few different attempts in the Kubernetes community, it seems like they are now converging around the cluster API interface. And you see this happening across some of the other providers as well. We see major vendors going towards cluster API. So we figured it would be a good idea to add that to Tinkerbell. In this release, what we are announcing is a proof of concept of cluster API. Now, it's actually already been out in the community for a little while, but we're going to give it a little bit longer after the release to get some more feedback from the community. At the moment, you can create and delete a cluster, and we're going to add some other functions later. And we've had certain people, if you go and look in the dev stats, you'll see all sorts of companies playing with this, and cluster API seems to have been one of the main drivers there. I think this is core, especially if we look at tooling, hybrid cloud tooling or edge tooling. Essentially, people want to have the same Kubernetes experience everywhere, even if they're running their own hardware. And I think the cluster API integration is going to be a big part of that. And then there was one more, which is the Action Hub. So one of the things we were interested in throughout is increasing the ability for people using Tinkerbell to contribute and reuse software. And we were inspired by the Docker Hub idea. So you remember earlier when I spoke about the workflows that are comprised of actions. Now, each of those actions is actually just a Docker image with a bunch of metadata associated with it. So it could be, like I said, format the disks. It could be upgrade firmware. It could be, partition disks, or install an operating system. Now what we have is something called the Action Hub, and it's hosted on the CNCF's Artifact Hub. And we have populated that with a bunch of basically core actions that people would use to get most things done, but they can also add their own. Now, the really fun thing about this is that for the first time now, the core primitives that people use to provision their hardware can be consumed by everybody and everybody can contribute. So much like in a Docker Hub where you could inherit from one of those, change it for your own use case, and then continue going and then share it back. Another area that's kind of interesting is if you look at the workflow at the moment around updating firmware on servers, in some cases, it's very much like updating the firmware on your printer. Even if you've got 1,000 servers, you probably still need to go to a website, type in the model number, and download a zip file. Now, obviously, you don't really want to be walking around a data center with a USB stick, and we don't do that either. But the supply chain of getting firmware updates from OEMs to people running hardware is still quite difficult. And we think that the Action Hub allows us maybe a way to do this in a more automated way, which is to say, if you're a hardware manufacturer and you have a firmware update, upload your firmware update to the Tinkerbell Action Hub, and then anybody running Tinkerbell will be able to download that automatically and apply it to their entire fleet without any extra tooling, because you can reuse the provisioning stack that you're already using to do all the rest of your work. So that's an early one, but it's one that we're very excited about.
If I'm not wrong, Tinkerbell was released into open source last year, and then it's now a CNCF sandbox project. Can you talk about the community aspect of it? Number one is that what kind of organizations or what kind of community you have built around the project and how it is being adopted? I'm sure there are many use cases where it's already been used in production.
I can't remember the exact date, but I'm going to say October of last year, we went into the CNCF sandbox. And it was interesting to see immediately after that, the uptick in interest from a lot of companies. We were already getting quite a lot of interest, but it was mainly coming from home lab type people with a few larger organizations in there. As soon as we went into the CNCF, suddenly bigger organizations started getting involved. And I think the reason why is that, if you want to use, some JavaScript library that's open source that's not super important in your stack, people don't care about the governance for that as much. But if you're going to install something like Tinkerbell, which is going to be core in making sure that your hardware investments actually do what you want them to do, then you want to be sure that there is open governance and that you can get a seat at the table for the roadmap. And I think joining the CNCF has really allowed us to do that. Looking at the CNCFs, one of the benefits of being with the CNCF is that you get included in their DevStats project, so it means that we can see very accurately who's committing from where, which companies they belong to. And it looks like if we keep tracking the way we're tracking right now, we're going to meet parity for internal and external commits in about 2 months, which is kind of amazing because 3 months ago, we certainly weren't tracking that way. Now, to talk about some of the more specifics, anyone can go to the DevStats and you'll see many companies in there, from Alibaba Cloud, VMware have committed quite a lot. The list goes on. But one use case that I want to touch on, and that is mentioned in the release, is Kubematic. So if anyone who's not familiar with Kubematic, they may know it through its previous name, which was Lodze. That's a company based in Germany and Hamburg. And they have been focusing for a long time on multi-master Kubernetes, and they're really starting to see some traction now. One of the things that their customers ask for very often is on-prem Kubernetes deployments, or even if not on-prem, on someone else's hardware, right? So not through a hypervisor. What they've decided to do with Tinkerbell is to build Tinkerbell into their stack under the name Tinkermatic. And they're going to be using Tinkerbell as the way that they get their clients' machines from essentially inanimate, expensive objects to running operating systems so that they can then go and deploy the Kubematic software on top of that. Now, the cluster API for Tinkerbell that I mentioned earlier has kicked up a lot of new discussions with larger companies, Kubernetes vendors, who are looking to solve this, both in the hybrid cloud space and in more usual configurations. And we're going to be able to speak a little bit more about that in the future, but we're expecting that the cluster API is really the thing that's going to make a lot of difference here for those vendors.
So this release is out here. Of course, this is an open source project, so anybody can go and check out what the roadmap looks like. But if I ask you what plans you have based on the community feedback, what should we expect, either new features or the problem that you're trying to iron out?
The way that we've been doing the releases at the moment tied to the internal planning here at Equinix Metal, that may change over time. But what that means is that we're currently tracking to plan next release for Q2, and our Q2 kicks off on April 16th. So the roadmap is still being firmed up, but some of the things that we know are going to happen for sure are there's going to be a bunch of refactoring. So in a sense, although you see areas like with OSI and Hook, where we've started to make changes based on community feedback, there are some other areas that still contain code that we think could be better. And we're going to spend a little bit of time doing that in Q2. There's also going to be a renewed interest on the Action Hub. So there's a lot more base actions that we think we can add in there. And we're seeing an increasing number coming from the community. So we want to really focus on that one because we think that, most people in the Tinkerbell community are eventually going to be users. At the moment, we've got a lot of people actually wanting to hack on how it works, but at a certain point, the number of people hacking on it is going to be less than the number of people using it. So we want to really make sure that that experience is as easy as possible outside of the box. Now, related to that is, I said earlier that we've done a lot of work on documentation, but that is a never-ending task. We keep finding new ways to either explain the product more clearly, or to explain new areas of how to use this. And I think what we're going to be including as we move forward is more stories about how others have succeeded with Tinkerbell, both to spread the word, but also to make it easier to consume. Also, we're going to continue work on the cluster API. So as I said before, we've implemented part of the interface, but we want to go and complete that because what we're hoping is that it will become the default way to deploy Kubernetes for companies like Cubermatic who have clients who would like to get their bare metal clusters
look back at the
ready.
Mark, thank you so much for taking time out today and talk about this new release of Tinkerbell. And I would love to have you back on the show. Thank you.
Swap, always a pleasure. Thank you very much. Bye-bye.